and this is one of my favorite topics, cellular adaptations. So depending on the stressor or stimulator, cells may undergo several different growth adaptations. Cellular adaptations include reversible adaptations that can be physiologic, think skeletal muscle hypertrophy in response to lifting weights, or pathologic, think cardiac muscle left ventricular hypertrophy in response to prolonged hypertension. We'll discuss more of these changes, but for now we're going to focus on atrophy. So here we have a sample layer of cells supported by a basement membrane, innervated by nervous tissue, and cultivated by vasculature. The vasculature offers red blood cells, nutrients, and hormones to the cells. All these things allow a cell to grow and to differentiate. So what is the growth adaptation that describes an increase in cell number? That would be hyperplasia. What about an increase in cell size? Good, that would be hypertrophy. If any of these things are disturbed, the cells will be affected. So in the case of atrophy, meaning literally without growth or to shrink, the cells decrease in size. You can think of atrophy on a spectrum with apoptosis. The triggers of atrophy are similar to apoptosis, however, they're just not quite as severe. So let's briefly discuss some of these triggers. If a nerve is injured or impinged, decreased innervation and stimulation of the nerve and of the tissue leads to tissue atrophy. So let's say a patient fractured the midshaft of their humerus and now they're presenting with wrist drop and numbness of the posterior arm, as well as the back of the hand and the thumb. What nerve do you think was severed and what muscles would you expect atrophy in? So wrist drop is pretty characteristic for radial nerve damage, and I remember the muscles with the mnemonic BEST. BEST, standing for brachioradialis, the extensor muscles of the forearm, the supinator, and the triceps brachii. So you can also have atrophy as a result of loss of blood and nutrients. Loss of blood supply and nutrients may lead to atrophy before the tissue becomes apoptosed. So recall, was this sudden onset or slow onset ischemia that would lead to this? This would be seen in slow onset ischemia, such as seen in renal artery atherosclerosis or fibromuscular dysplasia, and shrinking of the affected kidney. Sudden loss of blood flow, in contrast, would be seen in necrosis. So what about hormones? As discussed in the apoptosis section, hormone stimulation is required for preservation of some cells, such as the uterine lining. We can also have apoptosis as a result of compression. Compression of cells by anything, such as a tumor, hemorrhage, or backup of secretions, may lead to decreased blood flow and atrophy of the affected cells. So where could we see a backup of secretions? For example, when would a buildup of urine cause atrophy of the kidney? Well, how about if there's a urethral stone or a ureteral stone? What organ would undergo atrophy in an individual with cystic fibrosis? Well, in that case, it would be the pancreas because of the thick secretions blocking ducts and compressing tissues. Why do people with cystic fibrosis have thick secretions? Well, because they have a defect in pumping chloride ions into lumens. So positively charged sodium ions do not follow, resulting in water molecules not following either. So the absence of water in secretions makes the secretions thicker and capable of causing blockage. The same effect takes place in their airways. So for extra bonus points, can you guys tell me what chromosome is affected in cystic fibrosis? So cystic fibrosis is on chromosome 7, exactly. And that would be the CFTR gene. So let's talk about reversible changes. We'll first review the reversible changes that cells undergo before becoming unstoppable proliferators. Here we see the epithelial cells increasing in number. What is this called? Well, this is called hyperplasia or increased growth. This is different from hypertrophy, which again means increased in size. So next, we'll see cells losing their typical orientation, as well as their shape and size in comparison to normal tissue. What is this called? Well, this is called dysplasia, or abnormal growth, which is commonly pre-neoplastic, but still reversible. Sometimes one adult cell type is replaced with another. What is this called? This would be metaplasia. Good. Metaplasia is also known as transforming growth. The problem with this is that the DNA of cells must actually be altered, and recall that whenever DNA is altered, you run the risk for developing neoplasia. So far, these changes have all been reversible. However, if the chronic conditions that predispose to metaplasia persist, we're now at risk for irreversible changes, which have a much higher chance of leading us towards a neoplasm. So, flash quiz time. What growth alteration best describes an increase in cell number? Good, that would be hyperplasia.